Hey, what's good, you guys? Here in this video I'm going to introduce an additional example of using dynamic memory allocation with creating a matrix. So how it's going to get started is that we're going to create a header file and we're going to create a data structure that can contain a matrix. Having a matrix by itself it can get a little bit complicated in C because you need to keep track of things like how many rows and columns it has, right? And that can get easily lost in your program. So if we keep it as a structure, we'll be able to keep everything as a container and it'll be much easier to manage. So I'm going to do that by creating a file, accessing a file called mymat.h. Here we have a struct. I say struct underscore mat. It has three attributes. Right, there are three members that belong to the structure. Their names are data, row, and column. So we'll go from the bottom up. So I have an integer column, an integer row, and we have a double pointer to a double data type. So this gets a little interesting. Previously, I've only just showed you a pointer to a data, but now we have a double pointer that can point to, well, any other variable, right? So here in this example, I have a double pointer that points to a double data type. And for me to have a matrix, right, where I can do something like this, adding that second pointer, making data a double pointer, lets us have that J. So having a singular normal pointer like we've been traditionally using will only allow us to get what I like to say just one dimension, which means we can just access I. However, if we have a double pointer, we can get two dimensions, I and J. And you know, if I want to keep going, I can have a triple pointer where I can have like a three-dimensional matrix, and I can keep going, I can keep doing that. But here for this example, I just want to have a double pointer. Right, so one layer of the pointer is going to be representing the rows, and another layer of the pointer is going to be representing the columns of the matrix. So with here, why don't I go to main and see what we will do. How will we go about using this data structure, and what's going to be the process. So because I'm going to be doing dynamic memory allocation, I'm going to be needing stdlib.h. I have my mymat.h because I've written matrix now as a data type, as a custom data type. So here what I'm going to do is that I'm going to make two ever-present iterators. And what I'm going to do here now is I'm going to create my struct matrix, and I'm going to call it matrix1. Now I have, I created a structure. This one's created by the stack. It has unidentified data. So why don't I go about adding data to the matrix? So here, I'm trying to specify that mat1 is a 2x5 matrix. So I've specified the rows and the columns, but what about the data now? How am I going to go about the data? Well, what I'll need to do is that, because it's a pointer and I want to use it for dynamic memory allocation, I need to cast it to the pointer, that the specific pointer data that I wanted. And since data is a double pointer to a double, I'm going to do that. Now, here, it gets a little bit complicated because right here, I need to specify the rows of my data. So I'm going to say 2 times the size of double asterisk, right? So now with my double pointer, I'm going to be allocating 2 pointers to a double. And this is to specify the rows of my matrix. And well, here I have it hard-coded, but the best way to do it is I say mat1.row, right? So how many rows that I want, I'm going to specify a pointer to a double. So that's one dimension. How am I going to go about allocating data for the second dimension? Well, I'm actually going to need a loop. I'm choosing a for loop. So here, it's a little weird. Here I have a double pointer, which you can think of as a pointer essentially with 2 layers. So a double pointer is essentially a pointer that points to a pointer to a double. Okay, so a double pointer is going to contain an array of pointers to doubles, right? If it's just one value, a double pointer will contain a pointer to a data type. So since this is a double pointer, it's going to contain in its value an address that is a pointer to a double. So because of that, when I go down here, if I dereference a double pointer, I get rid of one layer of, pointerness. So when I dereference a double pointer, it just becomes a pointer to a double. Here, since I dereference my double pointer to a double, I get rid of one of the layers of pointerness, and it's just a pointer to a double. So I cast my pointer to a double with malloc, and here is more what you would typically see of normal dynamic memory allocation. But here is just 2 layers of pointers, right? And I have to do 2 layers of dynamic memory allocation. So now that I have this, I need to follow my best practices. And here when I'm done, with matrix 1, I first need to go inside of the matrix and I need to free all of the single pointers first. And then when that's done, I need to do free mat1.data. Using a double pointer and doing dynamic memory allocation for it gets a little bit complicated, because I need to do the initial dynamic memory allocation, which is done in line 13, and then I need to do the internal dynamic memory allocation, which is lines 14 through 16. And then when I'm done, well, if I want to free the data, I need to free the inner data before I free the outer data. So lines 18 through 20, I free the inner data of what's been dynamically allocated. And then in line 21, I free out the remaining shell of the data. This can be a little bit confusing, and in the next video, we're actually going to go through a visualization. So here's the code to do a dynamic memory allocation for a 2-dimensional matrix. It is done with a double pointer. In this case specifically, we're doing a double pointer to a double, and we allocate the data by first allocating memory for the double pointer, and then going inside of the double pointer and then dereferencing it, giving us just normal pointers, and allocating data for those normal pointers as we do in a for loop. So again, next video we'll go through visualization on how this is done, and I'll see you there.